right. Welcome, everyone. I'm Tom from Rasa, and welcome to the third day of Rasa Summit Talks. And I'm going to walk you through what we've been working on, with Rasa Open Source. All right. So Rasa Open Source, what's next? We're going to talk a little bit about what we've been working on for the past couple months since kind of the last major release. And then we're going to go on that journey and kind of take a look at what's next, what we're currently working on, and kind of what are the ideas that we have. We really want your feedback on that. We want your inputs, like if you have data sets that you want to share with us, if you have other ideas, if you, are researching some of these ideas and have great input, really do reach out to us, in the booth or in email or in on our forums or GitHub. Like, we're really eager to hear your thoughts on these topics. So we've released kind of our past major release 2.0 in October, and we're currently sitting on 2.3, which I think we've released a couple hours ago, so really fresh off the press. And after that, we're going to take a look at the upcoming releases. And you'll see a couple different topics popping up here in kind of linear order, but really we're working on them in parallel, and we might release them in a different order. They are mentioned here. So it's really just more visualization to make them all fit on this page. But before we take a look at what's next, let's take a step back. And I want to really make sure that you know about all the features that we've shipped in the past couple of months. So part of our 2.0 release, we shipped the rule policy, which is kind of a big step for us to kind of unify how we treat deterministic rules and kind of combine them with machine learning policies. This was a huge release for us, and there've been so many features that I can't even mention all of them. But I want to take a special look at the new training data format because it's super important for some of the features that we're currently working on. So here you can see a kind of casual conversation. I'm looking for a restaurant. How about Chinese food? Sure. Okay, here's what I find. And this is how that looks like in our training data, in our new training data format. And you can see it's in YAML. It's kind of a traditional YAML file with syntax highlighting. And you can see down at the bottom the stories and this particular story written in that new format. So why did we do that? Why did we change the training data format? I mean, it was a huge step for us, first of all, to come up with a new format. Also, making sure there's a good migration path. And we know that it's a huge hassle for everyone to migrate their training data. So why did we come up with a new training data format in the first place? So YAML is a well-known standard, right? And that has a lot of benefits. So we get good editor support. People know YAML, how to write YAML. And it is just a unified and extensible format. So the training data format for NLU and also for stories is a lot more similar now, which allows us to do some cool things that we're currently working on. And it's also a lot more extensible. So if we think about new features that we need to keep track of and need to annotate in our training data, we can do that with the YAML format. And we just hit limits with the old training data format. And that was kind of the starting point for us to think about this new format. So really kind of making it future-proof and being able to add more and more data as we progress and kind of keeping track of more information that we need to just build a greater system. And another great feature is it's composable. So you can split up your domain, you can split up your bot and your assistant into multiple pieces and then combine them when training a model. And hopefully you've seen Alan's talk, Alan's keynote at the beginning on the first day, and really think this is the future, being able to split up a bot and then combine that when building a model. It makes a huge, if you're writing a huge assistant that covers lots of ground, lots of different domains, it's way easier to maintain that over time if you're able to clearly separate the pieces and then combine them back again to train your final model. So this is why the YAML training data format really sets us up for the future and really allows us to work on our research topics, but also allow you to build better bots that you can maintain. Another thing that we shipped is new documentation. And hopefully a lot of people already saw that, but really try to aim for a better structure, more complete documentation. And I want to highlight one feature that I think is super cool and that I'm sure we're going to make more use of in the future as well, is the no install quick start. So we have that playground in there that allows you to work on training data in your browser, train a model right in there, and then talk to that assistant in your browser, right? No need to install anything. You can easily demo a bot. You can easily share something real quick with a coworker or show them some syntax. So we're really keen on this new feature on the playground in our documentation. And I'm sure we're going to expand on that and make that even better in the future. But if you haven't seen it, there's a link at the bottom into the docs. Please do check it out. It's really fun to play around with. In another release that we did, I think right before Christmas, we shipped incremental training. And I'm highlighting that because it allows us to do a couple more things. But let's take a quick look at how it works first. So you have your original data. You're going to train a model and using 100 epochs, so kind of training as long as needed to kind of get that original model. After that, you can annotate new data, hopefully using real conversations. So really do use real conversations, and then training just for 20 epochs, right? So not 20 epochs, but 20% of the epochs. So not kind of the whole, not the whole span, but really just a fraction of it. And your new fine-tuned model will just train a lot faster than your original model. And this will allow you to iterate quicker. It will allow you to train a model after annotating a couple new examples, train a new model, and then use that to iterate further. And just reducing that training time is a huge benefit in that iteration cycle. You can also do on-the-spot retraining. So we'll see what we're going to do with that in interactive learning, right, where you kind of modify that bot. And ideally, you could, after modifying the bot, really see that new model in action and kind of modifying that further. And again, composability, right? If you think about huge domains, about bots that span so many intents that you can't even count them in a single file, you need to split that up. And if you split it up and you change a small piece in one of the parts, it would require you to retrain the whole model. And making our journey on incremental training allows us to reduce that burden on the training time that you would encounter there. So you could change something in a small part of your bot and just train and fine-tune that model a lot quicker than you would need to do otherwise, right? If you would want to train a whole new model. So again, like super helpful for large bots when you want to compose different pieces together. Automated testing, right? So that's something that we shipped, actually not part of our normal release, but kind of outside. It's kind of a GitHub action, and it allows you to ship with confidence, right? We want to allow you to automatically test an assistant. It's easy to set up and it allows you to follow software engineering best practices. So you should always test your assistant to make sure there's no regressions. You want to iterate on that bot, and kind of this allows you to be sure that while you iterate on it, you don't have any regressions. So it's kind of standard practice that you also apply to other software projects. And so here's how that looks like. So you could create a new training, a new test story in Rasa X, copy that out, copy that into your test story set and a new test set. And then in this case, for GitHub Actions, we would train a model, run through all the test stories, train a cross-validation model on NLU, and then post these results on a pull request in this case. So this allows you to see how does that change on that pull request, change the model of the NLU that you've trained before. And you will see if kind of your new model is performing worse, or if it's performing better. And this allows you to see, okay, there's a regression. We shouldn't merge this pull request. We should roll back and then check why the change is resulting in this failure. And we've shipped these at GitHub Actions, and you can check them out in the GitHub Marketplace. And we're sure there's going to be more of these for different CI systems because they're kind of a template, and we can reuse them for different CI systems. But if you're running on GitHub, using GitHub Actions, do check them out and let us know what you think about them. All right, last feature I want to highlight is that we already shipped in 2.3. So as I said a couple hours ago, is machine learning model inspection. And that's an interesting feature because it's not necessarily a surface level feature, but it's something that we did under the hood to allow us to inspect models. So what you can see here is part of the Rasa Lit project. And if you haven't checked out that project, please go to Rasa HQ/Rasa Lit. And what we did there is we collected a couple different Streamlit applications that allow you to visualize certain parts of your models, your training data, and really allows you to kind of dig deeper into your models and your data. And what you can see here on the right-hand side is the TED policy inspector. And it shows you a lot more detail than you would usually get by just looking at the output of the policy. And this is just an example, but it kind of showcases that we can use this utilization that we did in Rasa Open Source to allow you to customize the models easier, right? So you can spin that up, check kind of what's going on under the hood. It allows us and other people to do better research, as we can see how does input change, for example, the attention rates, where do we see issues in these ways. And hopefully it will also help to debug in the future. So kind of being able to see why something fails or why there are certain patterns of failure inside your assistant. All right, so that was a lot of talking about the past, but I really want to spend some time talking about the future and talking about the features that we're currently working on. So what's next then? And the first thing I want to highlight is identifying unsuccessful conversations at scale. It's been a problem that we've been looking into for quite some time, and it gets more urgent as chatbots and assistants get more popular, right? More users will use your assistant, but we still want to enable you to really look at actual conversations and learn from them. And we want to enable you to understand where do users drop off, why do they drop off, and what can you do to fix that? And on the one hand, what we want to do is enable that in Rasa X using more powerful proactive filters. So for example, notifications to review new conversations, where a fallback action was triggered as kind of a fallback as a good signal that something went wrong, or a free text search, kind of allowing you to better explore that whole set of conversations that you've collected from lots of users. But at the same time, we also want to make and kind of utilize Rasa Open Source to allow us to kind of dig a little deeper into machine learning models and detect where something went wrong. And to do that, we're kind of working on a policy that we're currently calling intent TED. And that will allow us to detect where an unexpected intent was expressed and a kind of at which point in the conversation that happened. So we'll be able to kind of highlight that in Rasa X, for example, highlight that conversation and show you exactly where we think something went wrong, right? And even if no fallback action was triggered, right, even if kind of confidence scores are good, this will help us to dig a little deeper and get more insights into which conversations didn't go the right way. At the same time, we're also looking into continuous model evaluation. And that's an idea that we think is super important to support CDD. So we talked a little bit about testing earlier, but we also want to make sure that we're able to compare different versions of a bot, despite the fact that they might be working on different conversations. And we want to provide quantifiable measures of progress. And for example, we want to empower you to evaluate the impact of new features that you're adding to your bot, newly trained models, or maybe you're changing the components in your pipeline, and we want to be able to kind of quantify the impact that has. Another example is A/B testing, right? Let's say you spin up 2 different bots, and we really want to be able to quantify which one of these does better, even though they're kind of handling different conversations. And we think that is a great step forward in being able to iterate on assistants and kind of making them better over time. A really big project is breaking free from intents, and it's one that we've been working on, and we think it's gonna take a little bit more time to get that into production. At the same time, we think it's super important. We think intents aren't the future, but they're still very necessary right now, and there's gonna be a time that we need to bridge where we wanna use intents, and at the same time, we wanna move to adaptive assistance in the right direction. But adaptive assistance will never come if everyone sticks with designing and implementing hypothetical conversations, training and synthetic data, and kind of needing to put everything into a bucket and kind of labeling everything with a single intent. So to get to level 3 and beyond, we have to reinvent how conversation AI works. And here's a conversation that you'd usually expect. So I'm looking for a restaurant. How about Chinese food? Sure. Okay, here's what I found. So that is a conversation that you usually observe. But what users also do is, I'm looking for a restaurant. How about Chinese food? I had that yesterday. How about Italian food? Right. So that bot handled that really well, but this is tricky to do with just intents. So that's why we're exploring systems where you can combine intents with systems that don't use intents at all. And we've actually shipped something already, and it's called Experimental End-to-End Training. But as you can see, even though we shipped that as an experimental feature, we still need to do a bit more work to really get this over the finish line and make sure that this can be used on a larger scale. So in previous versions of Rasa, you would send your text to NLU, you would get out an intent, you would put that into a dialog manager, and you would get out the next action. Since Rasa 2.2, you can actually do both of these at the same time. So you would get intents, but you would also be able to send a text directly to the dialog manager and have that text influence the next action prediction. And that is the model that we want to explore more. And we're sure that's a good direction. We're not necessarily sure it's the final solution to get to level 4 or 5 and so on. But we know that it's kind of an interesting direction that will enable future use cases. And we're aiming to make this part of every assistant. And there's still some heavy lifting to do. So we need to refactor quite a lot of components and parts of Rasa Open Source. Some of you might know that we've traditionally separated things in NLU and core to kind of handle messages and handle dialogues. But we really want to be able to have this kind of shortcut to process text directly in a dialog manager. So through all these refactorings that we want to do, we really want to enable to do more research ideas, right? We want to explore more of the research ideas that we have to really be sure that we're moving in the right direction. And then we really be able to kind of handle the use cases that we've just seen on the previous slide. All right, last but not least, controllable NLG. Yeah, what does it mean even? It's controllable natural language generation. And what do we want to achieve here? So we actually want to adapt the response to the context. So currently that is possible, but you would need to write custom logic for that in every custom action that you have. So you could take a look at the history of the conversation and then programmatically select one template or the other, but that doesn't really scale. So we want to change that. And in addition to that, over probably a bit of a longer term, we also want to directly learn from examples, but, and that is the important part, guarantee transparent control for conversational designers and developers. We don't want to create an NLG model that just randomly generates responses, but we really want to put some boundaries on that to allow conversational designers and developers to direct the assistant and the bot into the right direction. How does this look like? So a really simple example is kind of mirroring users' word choices. So if you think about shoes, you can call them sneakers, runners, and kicks. And it would be really cool if your assistant would be able to pick up the phrasing the user uses. This will make sure that kind of the assistant is more appealing for the bot, the assistant is more appealing for the user, and the user has a better experience, right? They feel understood because you're kind of using the same language they are using. Another example is adjusting responses based on previous responses. So if you think about a situation where you're unable to handle a user request, the first time you would respond, "I'm sorry, I don't understand. Could you try rephrasing?" The second time you would say, "I'm sorry, I don't quite get what you mean. Would you like to speak to customer service?" And maybe a third time you would abort and say, "My apologies. Let's directly hand you over to customer service agent." This is already possible with Rasa. You can do that. You can store that state and do that kind of programmatically in your code. But we really want to make that easier and find a general pattern there to allow you to use that in all your assistants and the different use cases. All right, so that's the overview. That's kind of what we've been working on, and really brief overview of kind of what's next, what's on our radar. These are only some of the ideas. I couldn't cover all the things that we're working on. I think we've still 400 open issues on our GitHub, Rasa Open Source repository with lots of ideas, lots of enhancement suggestions. So this is really just a snapshot. And yeah, I'd be really happy to hear your thoughts, right? So comment on the GitHub issues. As you hopefully saw on the slides, I tried to link a lot of source material right on the slides. So where I took that information from, blog posts or GitHub issues. So feel free to explore that more and comment and let us know what you think. All right, that being said, as I said, lots of ideas. And if you're excited, also feel free to explore our job posts. All right, that's it from my end. Thanks a lot for calling it.